Alright, welcome. So we have 2.4, deductive reasoning. So our objective today is to use the law of detachment and the law of syllogism. So we talked about inductive reasoning as far as looking at observations, looking at patterns, and finding reasoning behind that. Now we're going to add on to it as far as deductive reasoning, and the two forms that are the law of detachment and the law of syllogism. So make sure you have the header written at the top, and let's get going. Alright, so we're going to make sure that we have right here deductive reasoning. We are going to write this down, this sentence right here, the definition. So deductive reasoning, sometimes it is called the logical reasoning. It's the process of reasoning logically from given statements or facts to a conclusion. So instead of looking at something and finding a pattern and coming up with reasoning behind it, inductive, we are given a statement or facts, and we're going to use logical reasoning for it. Okay. So also make sure that we have this right here, this take a note box. We should have all that written down as well. All right. So our law of detachment right here. What it says though is if we have a true conditional. So remember, our conditional is the if then. So if we have a true conditional statement, then if our hypothesis is true, then our conclusion would be true. So the reason why it's called the law of detachment is because if both of these are true, the if and the then separated, then they both would be true as well. So if you have the true conditional, the if and then if my hypothesis is true, then also my conclusion is true. So even if they are detached, that's why it's called the law of detachment. Okay? Alright, let's go on to our next one right here. Alright, so another part of deductive reasoning is the law of syllogism. So we're going to write the definition right here, the law of syllogism. It allows you to state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis and the other statement hypothesis of the other statement. Alright, okay. So you're going to get that whole written down, and you're going to write this whole box down as well. So the property of law of syllogism says this: if P then Q is true, and Q and R is true, then P and R is true. Okay? So make sure you have those symbols written down, and then the example right here. So what it says is, if it is July, then you are on summer vacation. If you are on summer vacation, then you work in a smoothie shop. So hence, putting those two conditional statements together, if it is July, then you work at a smoothie station. Okay? So let's think about it as far as like if I had pens right here. Say I have these three color pens. Alright? So if I told you that this pen, red pen, and this blue pen were the same height. Okay? And then I said that this blue pen and this black pen are also the same height. Okay? So from those two hypotheses, if I said those two are true, then we could say that the red pen and this black pen, they are both the same height. Now they didn't have a connection to start with, just like this P and the Q, and then we said Q and R. Well, because of these two now, we can say that P and R is true by using the hypothesis of the other two to make sure it's true. So before this, we said that these two had a relationship, so because these two, then these two, the black and the red one, which I never said had a relationship, can be the same height based on the two true hypothesis statements. Alright, hopefully that was clear. Hopefully the summer vacation one was clear, or my pen's the nice height. Hopefully that was clear. And let's look at an example right here. Just in case it's still confusing, let's do an example to kind of clear it up. Okay? Alright, so let's go over the example. So example number one. So make sure that you have example number one, and let's write down this question. So what can you conclude from the given true statement? So it tells us it's a true statement to start with. So it says, if a student gets an A on the final exam, then the student will pass the course. So we have right here, this is our hypothesis statement, so we can label this as P right there. And then I'll switch colors. And then we have our conclusion right here, which says then the student will pass the course. So this is our Q. So we have our hypothesis and our Q. So remember, the law of detachment says that if our hypothesis is true, then our conclusion is true, so even separated they are. So we can conclude that if Felicia got an A on her history exam, so if she got an A on her history exam, then what will happen? So we know that the hypothesis is true, so if you get an A on the final exam, then what will happen? Then the student will pass the course. So if Felicia got an A on the final exam, what will happen? She will pass the course. Alright, so that was our law of detachment, an example of that one. Okay? Alright, let's go to our next example. Alright, let's take a look at this next example. Alright, we don't need to write this down, but let's just make sure that we know law of detachment as far as what that means. So, if we were asked, what can we conclude from the given true statement? So, if there is lightning, then it is not safe to be out in the open. So, if there is lightning, that is our hypothesis. Our conclusion is then it is not safe to be out in the open. So, if that is a true statement, and we say that Marla sees lightning from the soccer field, then what does our conclusion need to be if our first statement was true? If she sees lightning from the soccer field, then it is not safe to be out in the open. So that's our law of detachment right there. So we said our first statement was true. If there's lightning, it's not safe to be open. Then because our hypothesis is true, that Marla sees lightning from the soccer field, then our conclusion also has to be true, that it's not safe to be out in the open. Okay, law of detachment. Okay. All right, let's go to our next example. You don't need to write that one down, by the way. Make sure. All right, but make sure we have this one written down. This will be our second example. So put example number 2. And it says, what can you conclude from the given information? So this is an example of our law of syllogism. So it says, if a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then the figure has 4 sides. Alright, so what I like to do with this is I like to underline and I like to label. So if a figure is a square, so this is going to be my Q, my hypothesis, then the figure is a rectangle. Alright, so let's do blue. Then the figure is a rectangle. So I'm going to say this is R. Nope, sorry about that. It should be if P then Q. So let's erase this. So this should be if P then Q. So if P right here, if P, our hypothesis, then Q right here, our conclusion. If P then Q, so if a figure is a square, then the figure is a rectangle. And then you see how it says again, if the figure is a rectangle, so this one is repeated. So this again is Q. Then the figure has 4 sides. So let's do this one green. Then this one is going to be R right here. So, alright, so what can we conclude from this right here? Let's say, we say, if it is, let's do this in black. Black right there. We say, if P then Q, if Q then R, so what can we conclude? P then R. So we can put those together. Alright, so we said if a figure is a square, then the figure is a rectangle. That's a true statement. So if those two are true, and if a figure is a rectangle, then the figure has 4 sides. And if that is a true statement, then we can take P right here and put P and R together. So what is that going to look like? We would say if a figure is a square, then the figure has 4 sides. The figure has 4 sides. So you see how before that P and R didn't have a relationship, but because P and Q were true, and Q and R are true, then we can put P and R. If a figure has 4 sides, if a figure is a square, then that figure has 4 sides. We can put those two together, our law of syllogism. All right, perfect, sounds good. See you guys soon.